Hi everyone, this is lecture number 5. We are going to discuss in this about the schemas versus instances. We will see about the 3 schema architecture. We will see about the data independence in this lecture. So we are going to discuss these things one by. First is the schema versus schemas versus instances. When we say about the database schema versus instances, the first important thing is what is database schema. Now before going into the greater depth at how a designer is going to make the database, or the important that how we are going to actually implement the database, the first important thing is the schema itself. So first is database schema. When we say about the database schema, that means it is the description of the database, and it includes the description of database structure and the constraint that should hold on database. So database schema is actually the description of the database, and it includes the description of database structure and the constraint that should hold on the database. So this is the simple definition that describes and defines about the database schema. Next is the schema diagram. Now, when we have created the database schema, or when we are going to define the database schema on the basis of the description, the next important thing is the schema diagram. What is a schema diagram? Schema diagram is actually a diagrammatic display of database schema. So whenever we are going to make the database schema, it is being described with the help of a diagram that is called as the schema diagram. Next is the database instance. What happens in the instance? What is called as the database instance? The actual data that is stored in a database at a particular moment of time is called as the database instance, also called database state. So we are having the database instance, that is actually the data that is stored in the database at a particular moment in time. This is called as the database instance. It is also called as the simple representation how the database is actually going to be defined. Now, when we say about the important point to note about the database schema, that is database schema changes very infrequently. We are not going to change the database schema at a frequent basis. That means the changes are inadaptable. We are going to fix the database schema, then only we will hope that the database is actually going to be implemented. If we are going to change the database at a rapid rate, that means the schema is changing, and every time it is not a good choice. So the database state changes every time the database is updated. Schema is also called as the intention, whereas the state is called as the extension. So the important point to note about the database schema is that it is not at all going to change at a rapid rate. What is going to change? The state of the database is going to change in every time. And the schema that we are having, the database schema, it is also called as the intention, where the state is called as the extension. So schema is called as the intention, while the state is called as the extension. Clear? Next is the 3 schema architecture. What happens in the schema architecture? We have seen about the database schema. The schema is not going to be changed at a frequent level. That means it is just the schema. Now the next important thing is the 3 schema architecture. That means how we are going to define the architecture. So it is proposed to support the DBMS characteristics for the program data independence and to support of multiple views of data. Why we need the 3 schema architecture? We need the 3 schema architecture to support the DBMS for providing the program data independence and to provide the multiple views of data. Now when we say about the database schema, or the database simply we look about the schema, then it is needed, the architecture is needed to define the DBMS schema at the 3 level. What are the 3 level? For the internal schema, for the conceptual schema, and for the external schema. So in short, we say that we are having the 3 schema architecture that comprises of the representation at the 3 levels of the database, that is at the internal level, at the conceptual level, and at the external level. So what happened? We can see, if we look in a diagrammatic representation, then this is the architecture of a 3 schema architecture. What happens in this 3 schema architecture? We are having the external view or the external level, we are having the conceptual level representing the conceptual schema, and we are having at the bottom internal level representing the internal schema. So we are having these three levels or the three schema architecture representing the three levels. At the top, external view where the end users are there. Next is the conceptual schema that is being provided by the conceptual level, and the third one, that is internal schema representing the internal level. Now when we see about these three levels, what does they define? See, at the top level is the external schema. Okay, I have written it in a simple manner, but at the top level, if you see, we are having the external schema. The external schema at the external level is used to describe the various types of views of the user. That means it is the external level and it is used to define the various user views. Each external schema, if you see, it describes the part of the database that a particular user is interested in and hides the rest of the database from that user group. That means why the database is being created, what is the basic theme is being represented by the external schema, while how it is being made, what are the internal description, what is the specification needed for the data type, for the internal storage, that is not being matter of concern for the external schema. So what does it do? It give, usually it uses the same data model as the conceptual level. So if you see about this diagram, this is the external level representing the external view. Next is the conceptual level. In this diagram, if you see, the second level is the conceptual level. What happens in the conceptual level? Conceptual level is at the schema representing the conceptual level, and it is being needed to describe the structure and the constraints for the whole database. That means it uses the conceptual or an implementation data model, and it actually hides the details of the physical storage structure and concentrates on being describing the entities, data types, relationship, user operation, and the constraint. So this is the conceptual schema. So conceptual schema is at the conceptual level to describe the structure and constraints for the whole database. It uses the conceptual or an implementation data model. It hides the details of physical storage structures and concentrates on describing entities, data types, relationship, user operation, and constraint. This is the second type of three schema architecture. Now at the bottom is the internal level or the internal schema, which is actually representing the internal level to describe the storage structures and the access paths. So in short, we can say that the physical data model is being used and it actually describes the complete details of data storage and access path for the database. Now if we see about these three levels, we are having one important thing in this diagrammatic representation, that at the top level we are having the external level, at the middle we are having the conceptual level, and at the bottom we are having the internal level. Every level is having their respective views, but between them there is an arrow that indicates that there is a mapping between the two. That means the external and conceptual mapping is there, and between the conceptual and internal there is conceptual and internal mapping. What does this mapping denote? This mapping denotes that we are having the mapping that is being needed at the schema level. Secondly, the mapping is actually the transforming request and result that happens between the different types of levels. So whenever we are having the levels or whenever we are having the mapping, that means the external view can be converted into the conceptual view, and the conceptual view can be able to represent the internal view. That means there is a mapping through which these three types of architecture, these three types of levels actually communicate and cooperate. So this is the three schema architecture. The important point to note about this, about the mapping, the types of transforming that happens within the schema levels on the basis of the mapping, and the program refer an external schema and are mapped by the DBMS to the internal schema. So this is all about the three schema architects. Clear? Next is the data independence. What happens in data independence? The data independence is defined as the capacity to change the schema at one level of the database without actually change the schema at the next higher level. That means, for example, if I need to change certain things in this diagram of three schema architecture, if I need to change anything inside in the conceptual level, that means if I enter through the external level, that then I have to change the external view also, then only it is being reflected in the conceptual schema, and then ultimately the changes will be made in the internal schema. But that is not at all being represented and possible when we say about the data independence. So data independence is defined as the capacity to change the schema at one level without having to change the schema at the next higher level. We are having the two types of data independence. Now when we say we are having the two types, what is first is the logical data independence and the physical data independence. What does the logical data independence says? Logical data independence says the capacity to change the conceptual schema without having to change the external schema and their application programs. While the physical data independence say the capacity to change the internal schema without having to change the conceptual schema. So these are the two types of data independence that work in the three schema architecture. One is the logical data independence and another is the physical data independence. Now there is one important point to note about these two different types of independence. When a schema is at lower level is changed, when a schema at a lower level is changed, only the mappings between this schema and the higher level schema need to be changed. The higher level schema themselves are unchanged and the application program need not be changed since they refer to the external schema. So this is the important point that clearly says if we are going to change the schema at the lower level, not at the higher level, and inside in the lower level it is only the mappings that actually needs to be changed. Actual schema does not need to be changed, while the higher level we don't touch, we don't need to change it, and it is being changed only with the application programs that need not be changed. They refer to the external schema. So this is all about the concept of data independence. Okay, thank you.